Hi everyone, welcome back to Organic Chemistry. Today we are going to talk about functional groups. Turns out that the entire year of organic chemistry is organized around functional groups. So, what are functional groups? Functional groups, it's a pretty generic definition, not too descriptive. It's just one or more atoms, group of atoms with characteristic properties. Yeah, okay, that's really generic. What we're talking about here are just groups of atoms within a molecule. And nature follows certain patterns. And it's up to us to memorize these patterns. Now, if you think about it, I know that's going to be something you have to do, but it's better than the alternative. Way back when organic chemistry was just being discovered and being, looked at, scientists were finding all sorts of molecules. They're saying, hey, there's a molecule that smells really nice. Here's another molecule that's reactive. Hey, here's another molecule you got that's corrosive. And they just listed molecules with their properties. And as they built, as they discovered more molecules, the list got longer and longer. And literally, there are millions of molecules that we know something about. And they're not going to ask people to memorize a million molecules, right? So how do we organize all this data? Well, you discover patterns, you discover trends. And it wasn't long before scientists discovered, hey, whenever a molecule, no matter what it is, has a certain group of atoms bonding in exactly the same way, they behave a certain way. It's a fundamental property of those groups of atoms. So, yeah, I know this list is kind of long, but it's better than having to memorize entire lists of molecules. Okay, so what do you need to do? Well, if I name a functional group, you got to be able to draw those groups of atoms, and then the reverse, right? So if did I say that right? You got to be able to draw the atoms when you're given the name of a functional group. Yeah, I'll give examples in a second. And you have to be able to name it if I draw the atoms. So name the functional group when I give you a group of atoms. Yeah, so go in both directions. So let's take a look at the list. Flashcards are helpful. Maybe you can find an app on your phone where you can plug these in. I bet if you search, you can actually find people who already made these lists, right? Because people around the world study organic chemistry just like yourself. So I'm sure someone has figured out a nice way to put this data in your phone and retrieve it. But here we go. First three functional groups are alkane, alkene, and alkyne. And what's helpful, since we have to memorize this, is to follow a pattern, right? So we have an A in alkane, an E in alkene, and a Y in alkyne. Hey, that's alphabetical order when we go from single to double to triple bonds. So that's a nice pattern. Okay, arene, that's the proper name. You can call it an aromatic ring. You can also simply call it benzene. I know there's some scientists who don't like that because benzene is specific to 6 atoms of carbon in a ring, alternating double and single bonds, and all those carbons are attached to hydrogen. However, this is one of nature's favorite functional groups. And so you can start benzene and add other groups onto it. So maybe at the end of these lines, there's carbons, or you can put nitrogen, oxygen, halides, whatever, lots of things. And then you might still say, hey, this molecule has a benzene ring in it, and I'm cool with that. So you can name this group of 6 carbon atoms benzene arene or aromatic ring. Right, so on the exam or on the quiz next week, I might draw this, and you don't have to give me all 3 names. Just pick one. Say, oh yeah, that's a benzene ring, or aromatic ring, or arene. Excuse me. You pick one, but of course, when I give you the name, I get to pick the name. So I might say, hey, draw a benzene for me, or hey, draw an aromatic ring for me, or hey, draw an arene. All right, some other functional groups. We got halides and alcohol and ether. So now we're bringing in oxygen. If you have one of the halogens, that's pretty easy. If you already know column 7 on the periodic table, fluorine, chlorine, bromine, iodide, then you can identify halides, the halide functional group. Oxygen is really popular, so you have to be a little careful. If you have an OH that's attached to carbon, and carbon is just doing single bonds, that's an alcohol. But if you have an OH attached to a carbon, and that carbon's also double bond to oxygen, this is not an alcohol group. It looks the same. It's got an OH group, but the more atoms you have, the more important it is, and the bigger group of atoms supersedes. It just wins, right? So I know there's an OH group, but you can't say this is an alcohol group because it doesn't behave like alcohol groups. This is a carboxylic acid. So be a little careful with that. Nitrogen does the same thing. When nitrogen is connected to a double bonded O, that's an amide. But if nitrogen is just connected to carbon and the carbon does not have a double bonded oxygen, there it is. Nitrogen just attached to carbon, no double bond O. It's not an amide, it's an amine. Okay, and so what I tell students, the amide is a C double bond O with an N, and the amine has an N here, so it's just plain old nitrogen. Maybe that's a way to remember it. Amine N, plain old nitrogen N. Amide, change the N to a D, and the D has a tall back to it to remind you that, hey, this has a tall group to it, a double bonded O. Yeah, work with me here. Maybe you can think of something better. Nitrogen's not done though. If nitrogen shows up double bonded, that becomes an amine. I don't know how much biology you've seen, but the amine functional group shows up in biology quite a bit. And so there in biology, they commonly call it a shift base. I'm not going to call it that. But if you call it that, I'll know what you're talking about. I've heard of amines being called shift base, so that's cool. Triple bonded nitrogen, I know. Probably in resolution of this YouTube video, you can't see that there's 3 bonds of nitrogen. There are. You should go to Canvas and download this list. I'll post it up there. And then you can see the triple bond. Yeah, so triple bonded nitrogen is a nitrile. And if you do more chemistry, explore more chemistry, there are other groups, functional groups possessing nitrogen, and they're not on this list. We're just doing the introductory level of organic chemistry, and so these are the most common functional groups of nitrogen. Sulfur shows up. Did I miss anything else? We had the double bonded O group. There it is. Okay, these are really important, especially once you get into medicine and biology and biological materials. Aldehydes, ketones, carboxylic acids, esters, amides. Oh my goodness, they play central roles in a lot of the molecules that keep us alive. Cool. But they all have in common is a carbon-oxygen double bond, and how they differ is in which group is attached to the carbon. Right? So if carbon has a hydrogen, those 3 atoms make up the aldehyde group. The other side is unspecified. Let's say there's an OH over here. Let's try that over here. And I ask you, okay, which functional group is this? Some of you might say, oh wait, Dennis, you just told us that C double bond O with an H is an aldehyde. That's 3 atoms. Yes, but earlier we said, hey, there are 4 atoms over here. C double bond O with an OH. That's a carboxylic acid. Darn it. Or maybe that was like the alert. Yes, it's a carboxylic acid. Sorry for my phone going off. Okay, more atoms, more important. That identifies a functional group. This molecule, okay, so I have memorized a few molecules. This is formic acid. This is the stuff that red ants inject into your skin when they bite, those stinging red ants. They're injecting a carboxylic acid in you. Why does it sting? Because when H is attached to an O, and the O is attached to a C double bond O, this hydrogen likes to fall off as an acid. It's a carboxylic acid. Good name for the functional group. So it turns out that's actually really powerful. If you look at a structure, brand new molecule, maybe it's been invented in a lab, it's never existed before on planet Earth, but someone created it in the laboratory. If it's got a C, double bonded to an O, attached to an OH, it will lower the pH in water. It's an acid. That's what carboxylic acids do. So by knowing your functional groups, you can make predictions about molecules that don't even exist. I mean, you can just draw on paper some crazy molecule. As long as it satisfies the octet rule, it probably could be made. It probably could be stable enough to make. And then you just start inspecting the functional groups, and you can predict what it might do. In fact, in part, that's the basis of drug discovery. Right? So if you want to create new pharmaceutical medicines, go explore some disease, find out what's happening there. Maybe there's a biological molecule that's not working correctly, and you either turn it on or turn it off. And so you can develop a new drug molecule that could do that. And the functional groups are the way to understand how the molecules behave, what their properties are. Cool. Let's see what else we got here. Yeah, that's the end of the list. Got a few memes down there. Just keep us all sane. You can look at those later. Okay, so I know it's a long list. So we're gonna have a quiz. That's a little motivation. Low stakes quiz though, right? It's not worth a lot of points. You get to drop a couple quizzes. We can do this. Make some flashcards, or get an app, whatever works for you. And this list is not something you have to memorize for the quiz and then you're done, forget it. No, it's going to be totally powerful. If you're going to have a career in science, you're probably going to encounter functional groups multiple times throughout your career. And definitely for the next year, this full year of organic chemistry, we're going to be just going down the list of functional groups. Let's see, what else can I impress you on? Let's look over here. So last year, I shouldn't say that because maybe this video is a couple years old now. At one point, I had a student send me this, and it's a little Venn diagram, but trying to find things that are the same, right? So I see circled right here, amide, amine, nitrile, and so this little Venn diagram is telling me, hey, these are all the functional groups that possess a nitrogen. And I like this. Maybe you can draw your own Venn diagram, or maybe you can use this to help you memorize things. Look at this. So the triple bond group is over here. Here's two functional groups, and that's kind of nice. If you want to know, oh man, which of the functional groups have triple bonds? Maybe you remember there's two of them. And then it's like, okay, what are they? Carbon-carbon triple bond, alkyne, carbon-nitrogen triple bond, nitrile. Yeah, I know, gotta memorize them. I've had a little practice. Okay, and this is just a little bit more specific example of why do we have to memorize these functional groups? Okay, as we go forward in chemistry in this class, we're going to explore each of the functional groups in turn. So when it's time for the carbon-carbon double bond, alkene, that's an alkene functional group, one of the reactions we're going to learn about is that a carbon-carbon double bond can react with Br2, bromine, elemental bromine. And what happens? Well, the carbon-carbon double bond has a sigma bond and a pi bond, and a pi bond goes away, or double bond becomes a single bond. But wait, carbon has to bond 4 times, so then what happens? Each carbon then attaches to one of the bromines. That's the fundamental property of an alkene. All alkenes do this. So in class, in a future video, we will talk about this reaction. And I'll say you need to memorize it. So I'll students say, okay, 2 C's with 4 H's double bonded becomes 2 C's, 4 H's, and 2 bromines. Got it memorized, Dennis. And then I give you this molecule on the exam. And you're like, well, I've never seen that molecule before. What are you doing to us? Yikes. Okay, so I want you to know right now, it's not about rote bulk memorization, it's about memorizing patterns. What's the pattern? The pattern is a carbon-carbon double bond becomes a carbon-carbon single bond when you add ER2, and the two atoms of Br bromine add to the carbons. That's the pattern. So then when you see this crazy molecule in the exam, you're like, the reagent's Br2. When have I seen that before? Oh, Br2 reacts with carbon-carbon double bonds. So hey, does this molecule have a carbon-carbon double bond? Is there an alkene? Yep, right here. Any others? No. Okay, so nothing else in the molecule reacts. So copy this molecule down here if you're predicting the product. But when you get to the double bond part, the pattern is double bonds become a single and the two carbons accept the bromine. That's it. That's cool. That's powerful. So now if you are working on a drug discovery team, and you're saying, you know what, this is going to be my next medicine and it doesn't exist, I have to make it. Well, maybe you can buy this molecule and add bromine to it. And knowing this pattern will allow you to make that correct prediction. Lastly, it's kind of zoomed in, but I think this will work. I just want you to be aware of two ways you can use a functional group. One way is how we've been doing it, just to identify groups of atoms. So I got this table down here, and I'll pose the question, hey, what functional groups are present in octanol? How many carbons would you guess is in octanol? I remember an octopus lives in the sea. An octopus has 8 arms. Yeah, octanol has 8 carbons. So down here in the table, there's 1 carbon over here, 7 more. Yeah, there's 8. Hey, here's octanol. What was the question? What functional groups are here? Okay, so the functional group functional groups are, we have an alcohol, and then we have, what is this? I don't see the bonds. A bunch of carbons. Are they double, single, or triple bonded? Well, remember honk. 1, 2, 3, 4. Carbon has to bond 4 times. So how many times did this carbon bond? 4. How is it bonding? Well, the 3 H's. Hydrogen can only bond once. So these hydrogens are connected by single bonds, and carbon just used up 3 of its 4 bonds attaching these 3 hydrogens. That gives only 1 more bond left to connect to the rest of the molecule. That's a single bond. Cool. Carbon-carbon single bonds are alkanes, right? Alkane, alkene, alkyne, alphabetical order. CH2 in the middle, it's got a carbon on the left, carbon on the right, 2 single bonds. Yeah, this whole group consists of a whole bunch of alkanes. The carbon-carbon single bond. Okay, so that's one way to use the word functional group, or how to use a practical way of using functional groups. Hey, just identify alcohol, alkene. Cool. But another way to use alcohol functional groups is that you can just group molecules together. You just identify a bunch of molecules with a common functional group. So what about this question? Which of the following alcohols which of the following alcohols dissolve completely in water? Man, I should proofread this before I get my video going. Okay, well, what are the alcohols listed? Well, this molecule has an OH group. It is an alcohol. You can say this molecule, the second one, also is alcohol. By the way, ethanol, that's a specific alcohol, a molecule with an OH group, found in beer and wine. Okay, propanol is another alcohol. Hexanol, octanol, these are all alcohols, molecules containing the OH group. And hey, looking at the table, the top 3 are completely soluble in water. So methanol, ethanol, and propanol are alcohols that can dissolve in water. Okay, that fact is not something I want you to memorize. We'll get into that later, how you can predict that pattern, which ones of these alcohols are soluble in water and which ones are not. Today, we're just introducing functional groups. All right, take care.